Good afternoon, RustConf, and good afternoon to the online attendees. My name is Yang, and I come from New York University. Thank you for attending my session. So today, I'm so excited to talk about Rust for robotics, safer, faster systems for autonomous applications. So before my talk, I'm going to ask a question. How many people are here have worked on or are currently working for robotics? Can you give me a, wow, that's so many people. And how many people are interested in robotics? Great. I'm so glad to see everyone here in the session. So today, if you are working on robotics, this talk is for you. And if you are a Rust developer and you are interested in robotics, this talk is also for you. If you know nothing about robotics, don't worry about that. This is not a super technical talk, so there won't involve a lot of jargons. So don't worry about that. And in this talk, I will share some stories from the Rust for robotics community. And I will talk about the current status, current challenges, and current opportunities in this field. So sit back and relax. Hope you can enjoy this talk. So a little bit self-introduction. I am currently a robotics PhD candidate from New York University. And my research topic focuses on multi-robot collaborative perception. I am also the founder of Rust for Robotics Discord group. And I am the lead organizer of the first Rust for Robotics workshop at International Conference on Robotics and Automation, ICRA 2025, in Atlanta, United States. And if you're interested to learn more about me, please check out the QR code. That will lead you to my homepage. Cool. So I will tell you a little bit my story about how did I dive into the Rust plus robotics field. Rust 1.0 was released in May 2015, so that was 10 years ago. And that was the first stable release. I was very lucky to study the Rust programming languages in my undergrad school at Shanghai Tech University in China. Our university probably was the first batch of academic institutes that actually provide an official programming course on Rust. And actually, there's also an operating system course that enforced us to write the toy operating system in Rust. That was a pain. And after that, I have studied and devoted my time on robotics research since undergrad, right now doing my PhD for 7 years. And during my PhD study, I spent quite a lot of time on system programming for robotics, and I'm working on autonomy stack, and specifically on drones. If you have been working on robotics, you may know that aerial robots are super hard, and it is a very brutal field, because we have to put all crazy payloads, and they need to run in parallel in the embedded system. And if anything is wrong, unlike a ground robot, the drone will fall from the sky. Hopefully, it won't crash onto you. And with more and more workloads that we are trying to put on our aerial robot system, we are really pushing the boundaries and the limit of the current robotics infrastructure and ecosystem. And I'm unsatisfied. I'm unsatisfied with the current status of the robotics ecosystem. So I become curious, like, what about Rust? Is Rust ready? I learned it 10 years ago. Now, 10 years later, can I actually start to use Rust to build robots? Therefore, I spent 1 month to work on a prototype of a minimal Rust-based quad-order autonomy pipeline to see possibility. So the GIF that you see here, it is actually a simulation of the quad-order autonomy. And you can see the simulated depth rendering. You can see the drone is kind of like trying to avoid obstacles and doing all different kind of curves. And surprisingly, this project is still on early phase, but that actually got onto the Hacker News. I'm super surprised, and I want to see, like, OK, this is something convincing. So I went to the New York City Rust meetup to see more like-minded person, to see more Rust experts, learn, and now I feel like, OK, Rust probably is ready for robotics. All this experience lead me to dive into the Rust for robotics field. So what is robotics? If you are software folks, robotics is basically equivalent to system programming. You have sensors, You have cameras, lidars. These provide observation, and they feed into the perception module. Perception module understand it and abstract these observation and give you a map. Basically, that will be abstraction of the environment. The planning module will reason about the best action according to the perception, and the control module translate these high-level command into low-level control command to the actuators. The actuator basically is motors, or you want to move the cameras, basically that make the robot move. There are several requirements for a robotic system. So you need to ensure low latency. If you have large latency, you will break the perception to action loop. The robot will lose control. And it is always a hardware-software integration problem. So you need to make the software and hardware mixed, and they are correlated. And you need to make sure the system is deterministic. You don't want the system to surprise you. And last but not least, robotic systems are safety critical. You need to ensure that the robot is logic safe and also memory safe. At the heart of the robotics, engineers and researchers are having an everlasting battle with the system complexity and all these challenges that I mentioned. Great. Now let's take a look at the current programming language landscape of robotics ecosystem. What kind of programming languages do robotics use every day? So C++ and C, of course, they stand out because of flexibility and high efficiency for real-time control and performance critical applications. C++ is also the major programming languages in the most popular open source robotics middleware called Robot Operating System, aka ROS. So we have ROS1 and ROS2, but ROS1 has retired, RIP. Python is also a very popular choice, especially for people who want to work on robotics, but also they have some AI and machine learning. So if you have some PyTorch, you still wanted to work with robots, so you probably choose Python. Java is also great because the cross-platform capability, and also it is a good option for enterprise robotics solution. And we have some population of MATLAB users in academic institutes. And surprisingly, if you're working on control, you will see a lot of control folks are still using MATLAB because they have extensive support for the control toolbox. OK, what are the issues? There are many issues. I will make it short because these are the issues that you may already know. A lot of languages are memory unsafe. If you don't use it properly, you will easily trigger race condition and undefined behavior. And also, some of the languages cannot guarantee real-time efficiency. And if you use unsafe code, there come a cost. We sent a Mars rover to the Mars. However, we almost lost that because of memory problem in the code. And Tesla, we all love Tesla. It's autonomous driving. But because of some software error, they record 2 million vehicles. So every segmentation fault in the code is equivalent to a potential catastrophe in production. Cool. How can Rust programming language help? So Rust programming language has a lot of properties that robotic people really appreciate. For example, Rust makes it super easy to develop multi-threaded applications. We do not need to fight against, for example, if you're using Python, you don't need to fight against the global interpreter lock. And Rust supports fearless concurrency that can handle intensive I/O operations efficiently. Rust is based on clear memory management design pattern based on the runtime. So it's pretty impossible to have a call after free bug if you're using C++. And also, it makes it effortlessly to work with cross-platform development. And also, the Rust tooling system make it super easy if you want to share your packages with the community. So a big shout out to the cargo system. And there are so many beautiful properties, but what about the community feedback? How does the community think about that? How does industry think about that? How does academia think about that? Therefore, we organized a workshop, which is the first Rust for Robotics workshop at ICRA 2025 to figure it out. So this is a whole day workshop. If you want to check out the recordings, feel free to scan the QR code. That will lead you to the page. We have 100 attendees. We have 8 speakers. And we have 4 poster submissions. We also hosted 2 panel discussions. We have 5 industry speakers and 3 academic speakers, a great balance. We also have companies brought their product. It's a Rust-based product to the workshop. If you see that small robot on the bottom part of the slide, you will see that's a vacuum cleaner, and it is a Rust-based. The company is called Magic Robotics. Feel free to check it out. It's amazing. So it was definitely a surprise for me to see so many people from the robotic community are engaging or interested in adopting Rust in the field. But also during the workshop, we heard a lot of questions, not only success stories. And these questions I will share with you in the following slides. And that's why I'm standing here in the RustConf to share with you about what's the issue, what are the challenges, what are the thoughts from the robotics community. First story, a safety story. So I'm going to list 2 companies and their product in this slide. So on the left side, we have Zhou. Zhou stands for Zero Overhead Network Protocol. And it is basically a communication protocol. In a robotic system, you have multiple components connecting together and talking to each other. And currently, Zhou has become the Tier 1 support RMW in the latest ROS 2 Qt release. So the community are welcoming the Zhou. It used the fearless concurrency of the programming languages to ensure safety. On the right side, we have CopperRS. It is a robotics runtime. So Copper, basically, it is 2 robots, what a game engine to games. It is a robotics runtime that tries to solve the robotics problem like a game engine. Both projects utilize Rust ownership, type system, and fearless concurrency model to ensure memory safety. And they also use explicit error handling provided by the Rust programming languages, and also the match statements. That both of these properties help a lot to ensure the code base is robust to the error handling. As critical infrastructure, communication protocols and runtime are pillars to the entire robotics system. They cannot crash or expose attack surface because of memory safety issues. We also heard great developer experience when people and ecosystem are adopting Rust. On the left side, Rerun is the data set for physical AI. It is a very great visualization tool if you want to visualize what's happening in the robotics. Whether it's 2D or 3D, they do a perfect job for that. On the right side, we have DoraRS. It is a framework that helps us to run AI and the robot system in a coherent ecosystem. Thanks to Rust, Rerun has native browser support with a WebAssembly. And they found it super easy to support different programming languages to support different kind of API with FFI. They also have great experience to manage one great code base easily thanks to the Rust tooling system. On the right side, DoraRS also uses FFI. That makes the DoraRS very easy to interrupt between the Rust core runtime with the Python program. So if you are a developer that knows nothing about the Rust, you can still use Python. You can still put the code that's running PyTorch, but easily can control robots with the beauty of the high efficiency of the Rust runtime behind. And at last, we heard a lot of performance story. That's the part I don't think I need to comment more about that. Rust really make the efficiency like easy pieces. So Rerun can visualize gigabytes per second of the data flow. DoraRS makes the Python interface, the runtime, 70 faster than the ROS 2 Python interface. Zhou can send 10 million messages per second. And the data flow architecture of the CopperRS can achieve sub-microsecond latency. Apart from the industry story, we also heard a lot of story and sharing from academia. A little bit different from the industry experience is that academia is still catching up. Not a lot of people, especially from professor perspective, they don't know Rust or don't know the beauty of the Rust or what is the difference between Rust and C++. So most of the research projects are initiated by students. The focus area of these projects are not on safety, but mostly on the high performance area. For example, the OPEN, it is an optimization engine that can help you to deploy nonlinear optimization on the embedded system. And we also heard great stories from Rice University. They are implementing sampling-based planning. So what is sampling-based planning? Basically means that if you are a car, instead of determining what is the best action about which direction to go or which speed you want to use, you are trying to just randomly sample a bunch of potential trajectories according to your dynamics model, then select the best one according to certain criteria that you choose. In order to do that, as you can see, this is like a highly parallel process. So you really want to making sure you have, you need to get the concurrency correct. You want to making sure the entire process has high efficiency. We also heard great stories from Yale University. There's an Apollo lab in Yale University led by Daniel Rakitas. So they are trying to build lab scale infrastructure. They have a monorepo. They are keep pushing code day by day, trying to build the lab scale infrastructure from scratch. And it was led by the professor. So that is really inspiring to hear that professors are actually trying to take a look at the Rust and adopting that in the labs. After all these successful stories, I will call that, we also heard a lot of questions, specifically from academia participants. So first question, is Rust stable? Some of the people who are asking this question are the people who are watching the Rust projects. They probably watch it like at 8 years ago or 4 years ago, and at that time, I think Rust is keep evolving. And the Rust API and some core system are keep changing. So they feel like, okay, if I want to use that in my projects, I need to think about that. I want to make sure that I don't want to keep maintaining and like fixing stuff because the Rust programming language itself are changing a lot. Fortunately, right now, I think the answer is clear. Rust is stable. So I answer in that way. Second question, do we have enough fundamental crates? That is an interesting question, especially for the robotics, because for robotics, the most important thing is deliver, whether you deliver a research or you deliver an actual robots. So it is pretty impossible to build every tool in-house. You don't want every company or lab just reinvent the wheels, and that's basically impossible. So if you don't have some like enough fundamental crates like matrix library or like optimization library, it will make it very hard for people to dive into this ecosystem. Third question, how to compare Rust-based middleware against C++-based middleware? That is probably the question I keep hearing. Also, when I'm asking the question during in the community room yesterday, that's also the question I heard. So people are thinking like, if I want to dive into Rust ecosystem, maybe I want to build everything from scratch. So I may want to like Rust native middleware. Is this middleware ready? Are these performant enough? And does this middleware like already have a large ecosystem? Do they have enough developers and participants? Fourth question, how to integrate the Rust components into the C++ code base? Because of course, not every company or the lab have the privilege to build everything from scratch. So people are interested in that. So we also observed that there is a big gap between the industry and academia. From the industry side, interestingly, since 2024, we saw that robotic companies are starting to hire much more Rust engineers than before, especially from startup. If there's a startup, usually they will think about it because they want to build everything from scratch, and they feel like Rust is the best choice. We also see some big mover in the robotics industry, like some big companies are also trying to slowly migrate their code base to Rust. Safety is the major reason for the companies moving to Rust. Performance is the second reason. And also from the industry, we hear very good feedback about using the Rust help improve the code qualities for junior engineer, because the documentation and also the Rust programming language itself basically enforce all developer write high quality code. On the academia side, very, very few institutes are teaching Rust, not only about like using Rust. Lab, if you have an academia lab, they have a very high cost to migrate C++ pipeline to Rust. They probably only have 4 or 5 PhD students. They also need to graduate. So, and also researchers in the academia lab, they are not super aware of the beauty of the Rust. They are not aware of the status of the Rust. So I think as the Rust community, we also need to do more promotions. And if you are researchers in the lab, you are basically building prototypes. You are not building products. And this prototype does not need to ensure the safety and the performance that much. They just want to publish a paper, prove that this is possible. So they probably didn't do things in that serious way. So they probably just said, OK, C++ ecosystem is good enough for me to work on. And we also talk about how can the Rust fit into the current robotics ecosystem. As I have seen this diagram before, Rust basically can fit in all stages. If you have a sensors, you can try to rewrite the sensor firmware into Rust to make it more safe and faster. You have perception, you can make sure that you can process the camera stream in a much faster way. If you are using planning, if you work on planning, you can make sure that you can use like high level and very parallel sampling-based planning. If you're working on control, you can minimize the latency from the perception to action loop. And if you have an actuator, that can also make sure that actuator won't surprise you. And the key components or like key principle is that if you want to adopt Rust into the robotic system, you want to replace the most critical 20% that cause 80% of the efficiency problem or unsafeness problem. You probably don't need to replace everything immediately. You definitely can migrate piece by piece, but focus on the most important part. How can Rust features help robotics? I have already talked a little bit about that, but as you can see, if you know async and await, that will make it very easy to write asynchronous programming for event-based processing. If you know embedded hardware abstraction layer, that can help you implement the sensor interface in an easy way. If you know Arc and the Mutix, that can help if you are working on state estimation and you are pulling multiple sensor streams into the algorithm and you don't want it to mess up, then Arc and Mutix really help. And the cargo make releasing the robot packages and like that prevent people just reinvent the wheels all by themselves. This is a slide that has a lot of information, but that's probably the most important slide or the most interesting slide for robotic people. People are interested to know what is the current status of the ecosystem. So I listed a few favorite crates that I like. So these are like personal favorites. But I talked to a lot of people in the community. A lot of people mention about these names. So we can take a look. So if you are working on Rust 2 ecosystem, you want to still write some Rust, you can take a look at the Rust 2 Rust and R2R. They making sure that you can still stay within the current Rust 2 middleware ecosystem, but you can write Rust code. And if you want to just write everything in Rust, you will have Rust native middleware. You can take a look at DoraRS and CopRS. They focus on different criteria, so pick the one that suit your applications. If you want to use a communication to do either wireless or wired communication, take a look at Zeno. And if you're curious to know that, oh, C++ have great eigen3 library in Rust, is there something similar? Yes, we have 3. We have algebra, we have ND array, we have VRS. I don't think On the performance side, they are exactly the same as the C++ library that we have right now. But I think they are close, and they are catching up. And if you're working on optimization, you can take a look at OPEN, as I mentioned before. If you're working on simulation, you can take a look at the Rapier and the Bavy. They come from the gaming industry. But if you want to build some simulation, they are a good fit. If you want to visualize the data, take a look at the rerun. If you just want to have very simple 3D visualization, take a look at KISS3D. If you are in the ROS2 ecosystem, Foxglove, it will be your friend to visualize the bag that you recorded from the robots. From the file loading part, MCAP is also the format developed by Foxglove. So I think people are migrating slowly just to use MCAP as the default format to store raw spec. Computer vision side, Corning RS is an alternative to OpenCV. And the Sophos RS is if you are working on geometry problem, you can take a look at that. On the machine learning side, we already heard the talk from Bird. That's a great library. We also have Candle. So both libraries can support training and inference. I think both libraries are trying to address the edge device inference problem, but I think we are getting there. We still miss a lot of packages. We need more device driver. If you have some cameras and you have some LiDARs, most of them probably don't have native support for Rust API. So this is a shout to all the hardware supplier for robotics. Please help the Rust community. Please write some Rust API for us to use. But of course, if you are open source contributor, feel free to support that for the community. We also need more algorithm implementation. For example, localization and mapping. For example, navigation algorithm. If you have a great implementation and share that with the ecosystem, that really help lift each other's up. And also, we need some more unified simulation platform. In the current C++ and the Python ecosystem, we already have some great standard simulation platform, like NVIDIA ISAC, if you try to have some photorealistic simulation. So in the Rust ecosystem, we are not there yet. And also, I feel like people just doing ad hoc simulation by themselves. And last but not least, better GPU support. I think that's a topic we have mentioned a lot during the RustConf. And I think we will finish, we'll get there in like 2 or 3 years. But that's something that, for me, I'm working on like learning-based system. I really hope that in the Rust ecosystem, we have better GPU support. I'm going to show you some of the simulation demo that I have worked on or I'm helping to build. So the first one, it is the quarter-order autonomy simulation that's running on rerun. So basically, what you can see here is that I can do the depth rendering. And on the bottom side of the screen, I can log the 2D plot of the velocity perception and also the gyroscope. It is pretty easy to plug in this visualization toolbox into an existing pipeline. And also, in this application, I also integrate some like optimization-based algorithm inside. So I would say it's a minimum prototype, and I just wanted to show people that it is possible to build things in Rust for robotics. In this demo, we are showing the CoPRS. I am also helping developing this runtime system. What we are showing here is that we are trying to balance this pool using a motor running on a pool. So you can see that we integrate a Bevy for the simulation part, but the entire application can run super quick under microsecond. Finally, what do we need? So as a robotics community, if we want to really push the Rust ecosystem, we need more open source contributor. We need guidance from expert Rust developer, from all of you here. And we need more meetup. We may need a working group to unite developers. And we want to make sure we have a smooth transition from the legacy C++ and Python code base to Rust. And we really want to bridge the gap between academia and industry. Yesterday, during the social time, I talked to several people, and we do realize that academia really need to catch up. Otherwise, the company, they really need some expert Rust robotics engineer. But if academia are not catching up, that will create an issue. Where are the next generation of Rust robotics engineer? So that is a critical issue that I am also trying to see if there's a way to get it done. Yesterday, during the in the community room, I hosted a discussion. There was a gentleman that made a very good suggestion, is that in order to promote it, we probably should have someone to hold a podcast and to invite different companies and different labs to share their stories and spread the news. I think I will think about that idea, but if anyone are interested, feel free to do that. How you can help as a Rust experts in the conference here. If you are an embedded developer, you can help us pour more sensor drivers. If you are an async expert, help build middlewares and operating system. If you are a game developer, help us build Bevy simulation for robots. And if you're still learning, feel free to join the Rust for Robotics Discord. Here's the QR code. I will also show that in the next slide, so don't worry about that if you missed this one. Finally, I want to make a big announcement. This talk basically is a digest of the first Rust for Robotics workshop at ICRA. And we are planning to host second Rust for Robotics workshop at ICRA 2026 in Vienna, Austria, in June 1st, 2026. So if you want to learn more about this event, join the Rust for Robotics Discord group here. And we will accept academic posters. We will accept robotics demo. We need speakers, and we need sponsors. So if anyone is interested in this event, come and talk to me. I am also one of the co-organizers for the second workshop. So really hoping to see more people are willing to contribute to this event. This is the last slide. I'm going to conclude with some key takeaways. First, Rust really improved the safety, performance, and the developer experiences. Rust addressed critical issues in existing robotics languages, in the languages that we use in robotics. And the Rust for Robotics ecosystem is growing rapidly. Finally, join us to build the future of robotics with Rust. I post my contact information here. So thank you, everyone. Robotic people love Rust, and let's build the future together. Thank you so much. Q&A. Yes, I can take some questions. If anyone has some questions, feel free to.
Oh, I didn't know we had microphones in here. I'm wondering if anyone in robotics is using Embassy's bare metal async facilities for doing robotics instead of using a real-time operating system.
I saw some example, but definitely it is not common cases. I think async is some properties that robotics, especially for the robotics Rust ecosystem and the community are looking at, but I don't see much examples.
Can you recommend any hardware platforms suitable for Rust, for robotics?
Yeah, that's a great question. Thanks to the cross-platform capability of the Rust, I think basically you can run Rust on anywhere. So for example, the Zhou communication protocol that I mentioned before, they basically run even on MCU on very low-end devices. And if you want to work on some you want to run some learning-based algorithm as well, you can take a look at NVIDIA Jetson platform. They have a GPU on that. But basically anything that, if it's a Linux-based system, you can definitely run Rust with that. I don't think there's limitation on that.
Hi. Let's say I have a robot project that I already have going, I've been working on for a few years, and I want to try and start using Rust in it. I'm probably using ROS already in my robot, and so probably a natural way I'd want to do that is by maybe writing a ROS node in Rust. What's that like? Can I write a ROS node in Rust on an existing robot where everything else is like in C++ and Python?
Yes, that's a good question. That's why I listed the ROS2 bindings here. So if you can use these bindings, basically that work like a bridge. You can write the core library in Rust, and you can use these two crates to work with an existing ROS2 ecosystem.
Yeah, great talk. So I have a quick question. So I know a lot of the existing projects, especially written in like C or C++, has like very, good tooling and good process for like, like formal process or verifications for the correctness of the system. So is there any effort on this in the Rust ecosystem?
Good question. Actually, that's a question that also bumped to us when we are working on the Corporate project. People are definitely paying attention on that. If you are interested, I hope that you can help us to solve this problem together.
Hi, so I was wondering, because I don't know a lot about pre-existing projects in the robotic space, but I think that there might be a gap that you mentioned about design patterns and a framework specifically for Rust to build systems, because I imagine some of us also use like Embassy, or we're all kind of writing the same code 1,000 times. Is there a library that is used in robotics in general that would be a good thing to look at if someone were to kind of look at like building a bootstrappable Rust library for robotics?
Thank you for the question. I don't think I'm in a position to like name one like golden standard here. I think that if you are, it really depends on certain application that you are working on. But I think feel free to check out the crates that I mentioned here. I think these probably can have some example that you can look at. But as I mentioned, this is a very new field and a new community. Nothing is settled yet. That's why there is opportunity for developers to shine here.
Maybe this is similar, but what about the people who like to write MATLAB?
Can you repeat your question again?
What about the people who like to use MATLAB, and how does that work with Rust?
That is a very good question. I have not think about that. Depends on what is the motive for the MATLAB user who may want to try Rust. I think that will be a very good opportunity if you already have some MATLAB code, but you really want to like reshape it to like modernize it. Using Rust will be a good option at the current time comparing to other languages because of these modern programming practices. So that will be my response. But from the perspective of guideline, I don't think I have any. Thank you for your question.
So, sorry, real quick. So this is maybe not quite a question, but an answer to the previous question. There's actually a company called Pictoris that's kind of like a Simulink for Rust. So not quite MATLAB, but Simulink. Sander, who's walking around interviewing people today here, works for them. You should talk with him, or come meet with me. I'll get you in touch with him.
All right, we can take one more question.
So it's very common in the Rust community of all of our developers to have lots of documentation and great examples and lots of good, easy to follow things for a lot of the projects. And that's not always super common in the robotics world, especially with a lot of the academia side of things. Do you know of any good example open source robotics projects that use Rust in their stack and like good as points of reference? Or maybe some good examples or tutorials that show using these various crates like you listed with, or the platforms like Copper and Rerun together for people who wanted to get started using Rust in their robotic stack? And if you don't know of any, do you have any plans to like start assembling something like that?
Thank you so much for this question. I want to clarify, are you asking specifically like some academia projects or any projects?
Anything for users who wanted to get started, do you have some reference?
Let me repeat the question. So the audience is asking if your user want to build something, can you find a reference of like good example? I would definitely recommend take a look at the Corporate project and the Dora project, and they are basically a runtime, but they have some example to like write your Rust applications. But if you're looking for some like very advanced Rust languages usage example, I will take a look at Zeno. I think Zeno has pretty cool implementation, especially on the async side. They use async a lot. I also learned a lot from that. Bevy is also a good example if you want to learn how to like use Rust properly. But as you have mentioned, probably right now there's no like golden standard to write Rust-based robotics application right now. Yeah, I think as a community, we should push through that. We should build some like more example for people to reference and use it as a like as a book. I think that's something that the community need to push forward. Thank you so much.
Let's hear it for young Zhou. Thank you.